Hello students, welcome to BYJU'S Exam Prep, most comprehensive app for all exams. Very good evening, and now we are going to discuss some important numericals on first order transient, right? And this is important for GATE 2023 and other coming exams, right? So first of all, inform me that sound quality, picture quality, everything is fine. Yes, please, everyone, please inform me that sound quality, picture quality, everything is fine. Now, first order transient or RC circuit. So that is my introduction. Myself Sanjay Sir, 20 plus years of teaching experience in the field of competitive exams like ECE, GATE and PSU, right? And I have secured these ranks: AIR 16 in ECE 2005 and AIR 21 in ECE 2008. And during my this teaching experience, I have mentored more than 1 lakh students. So please try to solve some important numericals on transient. Already we have discussed the theory of what RC circuit with source and RC circuit without source, right? That is also known as source free RC circuit. So first question, very simple question, that calculate the time constant of the following circuit. What is the time constant of the following circuit, right? Some important numericals on RC circuit with some questions on initial conditions, very basic questions on simple RC circuit, right? Simple but conceptual questions. So first question is what? Calculate the time constant of the following circuit. What will be the time constant of this circuit? Exactly at t equal to 0, that switch is open, right? Try to understand this concept. Exactly at t equal to 0, the switch is open, right? 1 ohm resistor, 2 ohm resistor, 6 microfarad and 3 microfarad capacitors. What will be the time constant of the circuit? Okay. So inform me that sound quality, picture quality, everything is fine. Okay then. Now, please try to solve this question. Then calculate the time constant of the following circuit, right? Like at that time this switch is open. So what is the series connection of capacitor? What is the C equivalent? The C equivalent is what? 3 and 6. So 3 into 6 divided by 3 plus 6, because these two are connected in series, and you will get answer 2 microfarad. C equivalent is 2 microfarad. What is the R equivalent? These two resistors, because that switch is open. That try to understand, this switch is open, and that's why this is the 2 and 1 ohm are in series. So what is this? 3 ohm. Now, what is the time constant of the circuit? R equivalent into C equivalent. R equivalent into what? C equivalent, that is the 3 into 2, 6 microsecond. 6 microsecond. That will be the answer for this question. That is the C is the answer for this question, right? So this is a very basic question, that how we can calculate the time constant, that is the 1 ohm, 2 ohm, 6 and 3 microfarad. So that is one question. Now another question, in the circuit given below, the switch has been in a position 1 for quite a long time, right? In position 1, this is the position 1 for a long time. This is the 50 volt battery, that please watch the polarity, 10 ohm, 100 ohm, that is the 1 microfarad capacitor, and this is what? 100 kilo ohm and 100 volt, right? What is the question? At t equal to 0, the switch is moved to position 2. Switch is moved to position 2. At this point, what is the time constant? What will be the time constant for this circuit, right? Very basic question. Again, you have to calculate the time constant, and please give me the what is the initial voltage across the capacitor. What is the VC0 plus? Everyone, as well as find the time constant. What is the time constant of the circuit, right? Initial voltage and what? Time constant of the circuit. This is the V. This is the voltage across the capacitor. So what is the initial value of this voltage and what is the time constant of the circuit, right? Chinmay Roy, sir, it is a current mirror circuit. No, it is not a current mirror circuit. Which one is the current mirror circuit here? Means which question you? Right. So first of all, try to understand. Always remember, when switch move from this position to this position, For t greater than 0, we are calculating the time constant for t greater than 0. When this is the circuit, 100 volt battery, and this is the capacitor. This is the 100 kilo ohm, and this is only 1 microfarad. Calculate the time constant. This will become very easy. RC is equal to 100 into 10 raised to power 3 into 1, that is the 10 raised to power minus 6, 1 microfarad. That is what 10 to the power minus 1 second means what? 0.1 second. That is the time constant. This is the answer for this question. Is very, very simple. That is the A, 0.1 second. Nitish Kumar. Number of batches for what? That is on which you asking about what batches on YouTube. That is the session for what? GATE 2023. GATE 2023. Important topics for GATE 2023 from network and other subjects. Right? So just I am going to take what some important topics like first order transient. Already I have discussed what RC circuit without source and RC circuit with source and some numericals. Right? So what is the answer for this question? This is the time constant. Now, what is the initial voltage across the capacitor? What is the initial voltage across this C? Now, if you want to calculate the initial voltage, now exactly for t less than 0, this switch is connected to position 1. This is the position. Now, at t0 negative, circuit is in what? Steady state. Circuit is in what? Steady state. Okay. Then we can make this circuit like that. 50 volt. Watch the polarity. This is the negative. Then 10 ohm. And this is 100 ohm. Now this capacitor will act as open circuit. This is the diagram exactly at 0 negative. 100 ohm and 10 ohm. Simple voltage division rule. This is the plus minus V. So what is the V0 negative is equal to V0 positive is equal to, that is the negative value because that is the polarity plus minus. So it will become minus 50 upon 100 plus 10 into what? 100. That will be the answer, minus 5000 divided by 110. Minus 500 by 11. This is the initial voltage across the capacitor. Yes, Arvind, exactly correct. That is the minus 500 by 11 with polarity because this is the negative value. Now, this will become the initial voltage. This will become the initial voltage across the capacitor. That is the time constant 0.1 second. Now, what is the final value? Because now this switch is connected to position 2 and that's why the 100 volt battery will charge it. 100 volt battery will charge, it means finally the voltage across this capacitor is what? 100 volt. Watch this. Finally the voltage across this capacitor is 100 volt. Okay. Now if the voltage across this capacitor is 100 volt, so what is the formula? What is the equation? Then Vc is equal to V final minus V final minus V0 e raised to power minus t by tau. Then what is the final value? 100. What is the final value? 100. What is the initial value? Minus 500 by 11 e raised to power minus t by 0.1. T by 0.1. And that will become the answer, 100. And now you can subtract it. This will become 1100 plus 500, that is the 1700. Please check my calculation. 1600, sorry. Right, try to understand. This is the when it is multiplied by the 11. This is become 1100 plus 500, 1600 divided by 11, right? And this is e raised to power minus 10t. So that is the equation. Now, what may be the question? At which time it will cross the 0? At which time it will cross the 0? Right? Nitesh, the BYJU'S team will give the answer for that question. Definitely you can share the your number on my Telegram channel. that is Electronics by Sanjay Rathi, and they will give you the information about all paid classes on what BYJU'S app. Okay, so Nitesh, please message me on my Telegram channel, that is Electronics by Sanjay Rathi. Okay, so ये है, that is the 100 minus 1600 divided by 11 e raised to power minus 10t. Okay, finally this voltage, try to understand, this voltage, this part will become 0. This part will become 0. Okay, so what is the formula? V final minus V initial e raised to power minus t by tau, and that's why this you are getting this answer. Now second thing, at which time it will cross the 0 line? Give me the answer. Means first of all, draw the curve. Let that is the 100 volt. Final value, what is the initial value? Minus 500 by 11. Now the capacitor will charge exponentially. That is the curve, and finally it will reach to 100 volt. Means at this point T1 it will cross the 0 axis. Okay, this is the 0 axis, and exactly at T1 it will cross the 0 axis. Now if you want to find the time, at which time it will cross the 0 axis, simply first of all get the equation, then exactly at t equal to T1, what is the value of the VC? 0. Put here, this is 0. 100 minus 1600 divided by 11 e raised to power minus 10, in the place of that T1. Now that simply you can take 100 as a common, it will become 16, and that is, yes, 16 by 11 e raised to power minus 10 T1, that is equal to what? 1, and this is become e raised to power 10 T1 is equal to 16 by 11. Take log of this and you can find the value of T1. Simply take the log of this and T1 will become 1 by 10 log of 16 by 11. 1 by 10 log of 16 by 11. Yes, तो मैडम यही है आंसर, सब चेक कर लीजिएगा जरा. तो आपको लॉग निकालना, अपने कैलकुलेटर आप लेकर बैठिए और कैलकुलेटर का यूज़ कीजिए. Yes, 1 by 10. So we are getting, yes, nearly equal to 0.03. Good. 0.037. 0.037 up to 2 decimal places. So approximately what? 0.037 means we can write 0.04. ये है आंसर. This is the answer. तो यहाँ से आप इसे सॉल्व कर लीजिएगा. Always remember, this is the e raised to power 10 T1. That is nothing but log of 16 by 11, and T1 is equal to 1 by 10 log of 16 by 11. That is the answer. Okay, so they may ask number of questions on this same diagram. Simple question, time constant. Second question, what is the initial value? Third question, what is the equation? Fourth question, at which time it will cross the 0 line. So this is the number of questions and on RC circuit. Okay, next question. Now switch S shown in the figure is kept in position 1 for long time. This is the position 1 for long time. When the switch is thrown in position 2, just that is the long time. This is the voltage V is here. Capacitor will charge up to what? V, means this voltage has the V voltage. Now suddenly it is thrown from position 1 to what? Position 2. Find at steady state condition the voltage and charge across the each capacitor respectively. What is the voltage and charge across the each capacitor respectively? So first of all, this capacitor will charge up to what? V volt. Now the switch is thrown from what? Position 1 to position 2. When switch thrown from position 1 to position 2, what will happen? since initially it has V volt and the value of both the capacitors are equal, and this capacitor, what is the initial voltage across this capacitor? Initial voltage across this capacitor is 0 and initial voltage across this capacitor is what? V volt. V volt. Now value of both the capacitors are equal and that second capacitor will act as what? Short circuit. So there will be infinite current for very small time, right? Infinite current exactly at t equal to 0, and because of this infinite current, capacitor will allow sudden change of what? Voltage. Normally capacitor does not allow sudden change of voltage, but in this case the infinite current will flow, and that's why the capacitor will allow sudden change of voltage. And simple voltage division rule, we have only two capacitors, and that's why what is the voltage across the each capacitor? V by 2 and V by 2. Okay, so that is the answer, V by 2. And second thing, what will be the charge? Q is equal to what? CV. What is the voltage across the capacitor? C into V by 2. That will be the charge across the each capacitor. Means normal case capacitor does not allow sudden change of voltage, but if there is impulsive current, right, if there is impulsive current or infinite current pass through the capacitor, capacitor will allow the sudden change. So on the same concept, please try to solve this question. This is very, very important one. General question. In the given circuit, the switch is closed at t equal to 0 plus, right? In the given circuit, the switch is closed at 0 plus. The initial voltages on the capacitors are indicated in the diagram. Initial voltage across the capacitor are indicated. That is the VC1 and VC2. That VC1 is 1 volt. VC2 is the 0 volt. The voltage VC1 and VC2 for t greater than or equal to 0 are respectively. What will be the answer? Okay, Karan, already we have taken 2 sessions. Now if you want, then we can arrange extra session for that. Okay. Okay. Then please tell me what is the answer. In the given circuit, the switch is closed at t equal to 0 plus. The initial voltages on the capacitor are indicated in the diagram. The voltage VC1t and VC2t for the t greater than or equal to 0. What will be the equation? Yes. Acha, Venu Kumar, you are asking how we are saying that impulse current is there. Venu, in this diagram, just everyone try to solve this question. Always remember, if this is the capacitor, first capacitor, it is charged up to V. Now what is the charge across the second capacitor? Nothing. That's why initially it will act as short circuit. Now this is the V, that is the short circuit. So what is the I0 plus? I0 plus is nothing but V by 0. V by 0 is what? Infinite impulsive current. And what is the voltage across the capacitor? Right? Q by C. This is nothing but 1 by C integral of I dt. If it is impulsive signal, 1 by C integral 0 negative to 0 positive I dt. Then capacitor will allow sudden change of voltage, and that is the reason. Capacitor will allow the sudden change of voltage. Okay, now when it is clear. Now just I will give one important question on this concept. So what is the answer for this particular question? In the given circuit, the switch is closed. Now what is the initial voltage across this capacitor? 1 volt. What is the initial voltage across this capacitor? 0 volt. According to law of conservation of charge, charge can neither be created nor be destroyed. So what is the initial charge? What is the initial charge across this capacitor and what is the initial charge across this capacitor? So first of all, Q0 plus. We can say V1 0 plus C1 into C1, V2 0 into C2. That is the initial charge. Now finally in this diagram, always remember, finally the capacitor will act as open circuit. What is the meaning of this concept? Means the current through the capacitor will be what? 0. Current through the capacitor will be 0 at t equal to infinite. First of all, close the switch. When we are closing the switch, that is the capacitor. It has initial voltage. This is the 1 volt. This is the 4 mega ohm resistor. Now this switch is closed. What is the voltage across the VC2? 0. That's why initially it will act as short circuit. What is the voltage across this? 0. And initial voltage across this is what? 1 volt. That's why the current will flow in this direction. Current will flow from higher potential to what? Lower potential. And what will happen then? Then this capacitor will discharge and that particular capacitor will charge. This capacitor will discharge and that particular capacitor will what? Discharge. Okay. Now try to understand. If this particular capacitor will discharge and this particular capacitor will charge, then tell me, finally at t equal to infinite, what will happen? The voltage at this point and voltage at this point will become equal. Like this is the VC2 and this is the VC1. So at t equal to infinity, VC1 and VC2 are equal. That is called V infinite. Right? If the voltage at this terminal and voltage at this terminal are equal, right? Voltage at those terminal are equal. Then what will happen? What will be the current? Current will be 0. Current will be 0. Right? This is the current will be 0. Now, if the current will be 0, right, then both the capacitor will act as open circuit, but the charge will remain same. That is the Q0 is equal to what? Q infinite. At Q infinite we can calculate the charge because the voltages are equal. We can say C1 V infinite plus C2 V infinite. So this will become C1 plus C2 V infinite. Okay. Now you can equate these two. When we are equating, we can find the V infinite is equal to, what is the V infinite is equal to? V1 C1, that is the initial value, plus V2 C2 upon what? C1 plus C2. C1 plus C2. That is the general formula for this particular question. Okay. So what is the answer? What is the initial voltage across the capacitor? First one, 1 volt. What is the value? 0.5 microfarad. So 1 into 0.5 microfarad you can multiply. What is the initial voltage across the second one? That is the 0. So that will act as what? 0 and plus C1 plus C2. So what is the C1 plus C2? 0.5 microfarad. 0.5 microfarad, it will become what? 1. So what is the V infinite? The voltage across the capacitor at infinity is given by 1 volt into 0.5 plus 0 volt divided by 0.5 plus 0.5, that is nothing but 0.5 volt. 0.5 volt. This concept is clear to you, everyone? Watch this. What is the initial voltage across this? 0. Initial voltage across that capacitor is 0. Initial voltage across that capacitor is 1 volt. Now we can, the charge will remain same, the V1 0, C1. So please check my calculation. This is the value, V2 0, C2. Okay. Then use this formula and find the final value. Now, if you have the 0.5 volt, what is the equation? What is the equation? We have the equation is equal to V final minus V final minus V initial e raised to power minus t by tau. That is the general equation. Now we have the initial value, we have the final value. What is the time constant of the circuit? Now these two capacitors are in series. These two capacitors are in series. So 0.5 microfarad means what? 0.25 microfarad. And this is the 4 mega ohm. So time constant will become C equivalent into R, that is 0.25 microfarad into 4 mega ohm. Mega and micro cancel and that is become 1 second. That is the time constant is what? 1 second, right? Now, for first capacitor, the equation will become, what is the final value? 1 by 2. What is the final value? 1 by 2. What is the initial value? 1 volt. E raised to power minus t by 1. And this will become 1 by 2. This is the minus minus plus 1 by 2 e raised to power minus t. Now you can take 1 by 2 common. 1 plus e raised to power minus t. That is the value of Vc1. What is the value of the Vc2? What is the value of the Vc2? We can use the same formula. Vc2. What is the final value? 1 by 2. What is the final value? 1 by 2. What is the initial value? 0. E raised to power minus t by 1. 1 by 2. 1 minus e raised to power minus t. 1 by 2 e raised to power minus t. That is the voltage across what? C2. Voltage across C2. ये है answer for this particular question. So what is the answer for this question? That is the final value is what? 1 by 2, right? And then you can choose the option, first option, second option, third and fourth one. Now, right? So Vc1t and Vc2t. So we are getting this answer. वन मिनट प्लस थोड़ा साइन को चेक कर लीजिएगा ज़रा, आपने प्रॉपरली साइन ये और ये सब चीज़ों को यूज़. अब देखो, मान लीजिए आपने आंसर निकाला. सपोज इन एग्जाम हॉल वी आर मेकिंग द somewhat calculation mistake, right? Then if we are getting this answer, suppose we are getting that answer exactly at t equal to 0, please check the answer. Already we have the initial value, and that's why exactly at t equal to 0. What is the answer from this one? Exactly at t equal to 0. If we are putting the t equal to 0, this will become what? 1 plus 1, that is the 2. 2 divided by 2, 1. We are getting the right answer. Exactly at t equal to 0, e raised to power 0 will become 1. 1 minus 1, that will become 0. That is the correct one. It is giving the initial value. Correct initial value. Finally, from the answer you can check and you can give the right answer for this question. 1 minute, I think there is a okay, that is the C is the option. C is the option. Okay. क्या है हनुमंत राव advice for this to how to get the strong perfect concept clarity? So first of all, go through go through theory. Try to solve some important numericals from standard textbook. Standard textbook means what? For example, Sadiku for network, and after that Van Valkenburg. Try to solve numericals, right? And try to solve some selected unsolved numericals, okay? And then go for what? Previous year question. And then simply previous year question of what? Electronics, electrical and what? Instrumentation branch. Ultimately you will get the common, okay? That is the way, simple strategy. So this question is very, very important. This is the first general answer. Remember that how we can find the Q0, then Q infinite, equate these two and get the V infinite, and then finally use this formula. This is very, very important one. Okay, and then tau C equivalent R, that is the time constant. Both the capacitors are in series, and that is the answer. Now watch this question. Give me the answer for this particular question. Let this is the 10 volt battery. This is the capacitor. This is the R1. This is R2. Now that is the C. Exactly at t equal to 0, that switch is closed. The value of this C is equal to 2 farad. You can take any value. Let this is the 2 ohm. This is the 4 ohm. Okay. Now, initially circuit is unenergized, means the initial voltage across the capacitor, we can say unenergized. Exactly at t equal to 0, the switch is closed. At t equal to 0, switch is closed. Right? Find VC0 plus. What is the voltage across this capacitor exactly at t equal to 0? Tell me. What is the answer? Very simple question. Very simple question. Right? Exactly at t equal to 0, the switch is closed. Right? Initially the circuit is unenergized. When we are closing the switch, that is the 10 volt battery, this is the 2 ohm resistor, this is the 4 ohm resistor. Then what is the final voltage, what is the initial voltage across this particular capacitor? What will be the value? Right. So capacitor, right, simply, capacitor does not allow sudden change of voltage. We have idea about that. So in this case, if the initial voltage across the capacitor is 0, when we are closing the switch exactly at t equal to 0, we have idea that VC0 negative is equal to VC0 positive is equal to what? 0. Okay, no problem. Now calculate the current. Initially the capacitor will act as what? Short circuit. Initially this capacitor will act as short circuit because there is no voltage, and this is R2. It will short circuit the R2 also, and this is the R1 is equal to what? 2 ohm. What is the initial current? Initial current is nothing but 10 divided by 2, that is the 5 ampere. Okay, no problem. 10 divided by 2, that is the 5 ampere current will flow. That is the finite current. Okay. Now for second question, this is the 10 volt battery. Now this is the capacitor. Again the value of this is the C2, like this is the value is 2 farad. This is the 4 ohm resistor R2. This is the R1. Now here we are connecting one capacitor. Like this is the C1. And the value of this C1, right, like this is 3 farad. This is the 10 volt. Exactly at t equal to 0. Now the switch is closed. Tell me, in this case, what is the initial voltage across VC2? What is the initial voltage across VC? That is the C2. Initially circuit is unenergized. Initially circuit is unenergized. Tell me. Now we have two different questions. In first question, this is the R2, we have one capacitor only, and that is the R1. We are calculating the voltage across this exactly at t equal to 0 plus. Initially circuit is unenergized, and that's why the capacitor will not allow the sudden change of voltage. So that is the 0 volt. But in second case, we are having the two capacitor. It is visible to you. This is the C1, that is the C2, R1 and R2. This is the 2 ohm and that is the 4 ohm resistor. Now this is the 2 ohm, that is the 4 ohm, this is the C2, that is the C1, and this is the 10 volt battery. Now what is the initial voltage across the capacitor? That is the question. So in this case, what will be the answer? Please give me the answer for this question. Yes. In this case, try to understand. If we are giving the 0 answer, then suppose if I am giving the 0 answer exactly at t equal to 0 plus, let VC1 and VC2, voltage across the capacitor C1 and voltage across the capacitor C2 is what? 0, right? if the voltage across the VC1 and VC2 is 0, then this capacitor will act as short circuit, this capacitor will act as short circuit, both the capacitor will act as short circuit. Okay, and if both the capacitor will act as short circuit, that is the 10 volt. When we are applying the KVL, Kirchhoff's voltage law, so this 10 volt is equal to, because there is no drop, it will become 0. How is it possible? It is not possible, right? Okay, Rajesh. So when both the capacitor will act as short circuit, then 10 volt will become 0. It is, KVL is violated. KVL is violated, right? So आप क्या करें? Now to satisfy the KVL, capacitor will allow the sudden change of voltage. Capacitor will allow the sudden change of voltage. Now watch this diagram. Exactly at t equal to 0, Venu, please watch this. Now this capacitor will act as a short circuit, this capacitor will act as short circuit. If both the capacitor will act as short circuit, so what will be the current? The current exactly at 0 plus will become what? V by 0. That is the infinite current will flow. Infinite current will flow. Okay? When infinite current will flow, or impulsive current, then capacitor, there will be a finite charge. So what is the charge? That is integral of I dt. 0 negative to 0 positive, and this is the infinite. And then finite charge is given by C equivalent into V. What is the C equivalent? Both the capacitor are in series. So C equivalent becomes C1 C2 by C1 plus C2 into V. C1 C2 by C1 plus C2 into V. That is the charge. Okay, exactly at t equal to 0 plus, and both the capacitors are in series, and that's why the same charge will flow. What is the voltage across the second capacitor? VC20 plus is equal to Q0 plus upon what? C2. Simply when it is divided, this answer will become C1 plus C2 into what? V. What is the answer? C1, what is the value of the C1? Let 3 farad, C1 3 farad, this is the 2 farad into 10. So this will become 6 volt. This is the initial voltage across the capacitor, right? In this case, Rajesh, the capacitor will allow the sudden change of voltage. And what is the VC1? That is the 4 volt, 10 minus 6, but we can calculate by using the voltage division rule. It will become C1 plus C2 into what? V. That is 2 into 10 divided by 2 plus 3. 4 volt. This is the 4 volt, right? That is the answer for this question. Now, this is the initial voltage. That is the initial voltage across this capacitor and initial voltage across that capacitor, right? So this is the answer. Are you getting me, everyone? So we have some exceptional cases, right? Please watch those exceptional cases and then try to solve that particular question. Okay. Okay then. Now, one last question for you. What is the answer for this question? Very, very simple one. In the circuit, if VC0 is 25 volt, VC0 is 25 volt, means initial voltage is 25 volt. Source free RC circuit, the expression for VCT for t greater than 0. Expression for VCT for t greater than 0. What will be the expression? Initial voltage is 25 volt. This is C is given, that is the resistor is given. What is the time constant of this circuit? And what is the answer? Okay, बताइए जरा क्या होगा? Yes, it is a source free RC circuit because there is no battery. right? We have the resistor 10 ohm, 4 ohm, 6 ohm. 4 plus 6 is what? 10 ohm, 10 ohm resistors and one capacitor. Okay, then source free RC circuit means there is no source. Simply you have to calculate the time constant. What is the time constant? RTH into C. What is the RTH? First of all, remove this capacitor, like this is the A and this is the B. So across A and B, find the RTH. What is the RTH? This 10 ohm resistor and this is 4 plus 6 10 ohm resistor are in parallel. What is the RTH across AB? Will become 10 parallel with 10, that is the 5 ohm. Now, this is the 5 ohm, that is the capacitor. So 5 into 0.1 farad. What is the time constant of this circuit? 5 ohm into 0.1 farad. This is become 0.5 second. 0.5 second. Okay. Now, what is the final value? 0. Why? Because there is no source, so final value is 0. At t equal to infinite, it is a 0. And we have the general answer, V final minus V final minus V initial e raised to power minus t by tau. What is the final value? 0. 0. What is the initial value? 25. It is given in the question. E raised to power minus t by what? 0.5. That is the 10 by 5, that is, it will become 2. So what is the answer? 25 e raised to power minus 2t. 25 e raised to power minus 2t. Yes, Venu, your answer is correct. Your answer is correct. The answer is what? D. So, my dear friends, if you want to solve this type of questions, right, so try to solve some questions from standard textbook like Alexander and Sadiku and what? Van Valkenburg. Okay, number of questions, number of conceptual questions on first order RC circuit and first order RL circuit, and with what? Initial condition, right? In every case we have to use the same formula, but you have to calculate what? Time constant, what is the initial voltage and what is the final voltage, or in case of inductor, what is the initial current through the inductor and what is the final current through the inductor, right? So this is all about the RC circuit. You are on BYJU'S Exam Prep, most comprehensive app for all exams, right? Thank you for attending the session. Okay then, thank you and good night.